Welcome in .core. Researchers discover dozens of new exoplanets each year, and it's quite possible that soon we'll find a world similar to the Earth that we can inhabit. In fact, scientists just picked up a signal from an exoplanet in the habitable zone they say can only be technological. But how would humanity travel to these alien exoplanets trillions of miles away, and what kind of technology would we need? It seems nearly impossible to journey so far across the universe, but scientists have recently discovered something in our own solar system that might allow us to travel faster than was previously thought possible, and we've just picked up. Before we get into that, let's explore some of the universe to show just how far away some exoplanets are, how fast we'd need to travel to get to one, and what kind of technology we'll need to get there. The closest system to Earth is Alpha Centauri's triple star system, and the third and faintest of these stars is Proxima Centauri. Two exoplanets orbit this red dwarf, and one of them, Proxima b, lies in the habitable zone. And now alien hunters from the Breakthrough Listen project have just recently picked up a strange radio signal coming from this system. It occupies a very narrow band of the radio spectrum that typically only comes from human-made satellites and spacecraft, raising the prospect of a transmission from some form of advanced extraterrestrial intelligence. Where is this mysterious transmission coming from? And if we had to get to Proxima b to find out, how would we get there? The biggest obstacle to space travel is the distance we'd have to travel. Proxima Centauri lies 4.2 light-years away from Earth. A light year is a distance that you can travel in 1 year, which is nearly 6 trillion miles. If you can travel the speed of light, which is 186,000 miles per second, it will take you 4.2 years to arrive. Currently, we have no technology that would allow humans to travel this fast. The fastest spacecraft is a Parker Solar Probe, which is on its way to the Sun. On October 29, 2018, the probe reached a speed of 154,000 miles per hour. By the time the probe flies at its closest approach to the Sun, it'll be traveling at 430,000 miles per hour as it's pulled by the gravity of the Sun. Even at this speed, it would take the probe 6,600 years to get to Proxima Centauri. But just how fast can humans travel safely in space? The current speed record is held by 3 astronauts who flew NASA's Apollo 10 mission. On their way back from a slingshot lap around the moon, the Apollo space capsule hit a peak speed of 24,790 miles per hour. At that speed, it would take 113,000 years to get to the Alpha Centauri system. Chemical-powered rockets have taken humans to the moon and have made countless missions into Earth's orbit and have powered long-range missions inside and outside of our solar system, like the Mars rovers and the Voyager probe, which was launched in 1977 and is now in interstellar space. Speeds of 20,000 miles per hour seem fast, but it's not fast enough to travel to distant exoplanets or the countless star systems that surround our own solar system. At a maximum speed of about 17,600 miles per hour, it would have taken the Space Shuttle 165,000 years to reach Alpha Centauri. But the problem with current space travel is rockets need to be refueled, and there are no refueling stations in space. We need something else to power our spacecraft. The direct fusion drive is a futuristic and conceptual low radioactivity nuclear fusion rocket engine that will be able to produce thrust and electric power for interplanetary spacecraft. The drive is now in development at the Princeton Plasma Physics Laboratory, and the researchers working on the engine hope to launch it into space to test it and hopefully use it as a primary drive for spacecraft for use in our solar system. And there's one fascinating target in the outer solar system that's similar to Earth in many ways, Titan. If you haven't seen our video on Titan, then be sure to check it out by the link in the description. Aerospace engineers say that direct fusion drive could be used to send a probe to Titan in as little as 2 years compared to the 8 years it'll take the Dragonfly probe to reach Saturn's moon. The good thing is that it seems there is no real practical limit to how fast humans can travel in space other than the speed of light. Speed, defined as a rate of motion, is not a problem for humans physically as long as the speed is constant and in one direction. In theory, humans should be able to travel at rates just short of the universe's speed limit. But if we do overcome the technological obstacles of building a faster spacecraft for humans, our fragile and mostly water bodies will have to deal with new hazards that come with near-light speed travel. This means we would have to ramp up and down from those speeds slowly, because rapid acceleration and deceleration can be fatal to the human body. This is because of inertia, whereby any object with a mass resists change to its state or direction of motion. An object in motion stays in motion at the same speed and direction unless it's changed by an outside force. Let's imagine for a moment that someday we do find a way to travel at the speed of light. If we wanted to get to the sun, it would take us just 8.3 minutes to reach our destination. But the universe is unimaginably big, and let's say we wanted to travel to the closest big galaxy, Andromeda. It would take you 2.5 million light years. So even if we were able to design and build a ship that can travel at the speed of light, our destinations will be limited. We would need something more. Warp drive technology is something many of you have heard of from science fiction, where drive would allow us to manipulate space-time itself and take advantage of a loophole in physics to move faster than light. This sounds impossible, but the closest real thing is a theoretical construct known as the Alcubierre warp drive. The idea comes from Mexican physicist Miguel Alcubierre, who proposed a valid solution to how space-time and energy interact and believes that bending space-time could be the solution. But how would this work? Let's go back to Proxima Centauri and let's say we have a new and improved ship with the Alcubierre warp drive technology installed. As your ship would travel to its destination, it would cause space ahead of it to contract, while the space behind the ship would expand. The ship and its crew would be moving in space-time in what is called a warp bubble of flat space. It sounds like science fiction, but now some physicists say that it could be possible in the future. But what about wormholes? They've never been seen, but Einstein's theory of general relativity mathematically predicts their existence. Imagine for a moment if there was a way to open a hole in the fabric of space-time in a way that's curved so that you could take a shortcut from one place to another. If this was possible, you might not need a ship capable of light-speed travel. Hopping through a wormhole would be incredibly difficult, but no scientists have ruled out the possibility. To show you how this would work, imagine the universe as a two-dimensional sheet. Make two holes at the end of the sheet, and then bend the sheet so that the two holes are aligned. Then stitch the two ends of the holes together, and you get a wormhole. It sounds more like science fiction, but objects like our sun and the earth already warp and distort space-time. In order for a wormhole to stay open and not collapse, you would need exotic matter that had negative energy or negative mass that would act like a sort of antigravity. To put this into perspective, if the Earth had negative mass and you let go of a ball standing on the surface, it would accelerate up into the sky. And to hit a negative mass tennis ball, you would swing your racket away from the ball. However, this exotic matter isn't known to exist. The problem with the theory of wormholes is that we'd need more negative energy than the rules of physics allow. To give you an idea of how much we'd need, the energy the sun produces over 100 million years to open a wormhole the size of a grapefruit. And no one knows how even the most advanced civilization could harness this much energy. But there is something real that was discovered by scientists in our own solar system that will allow us to travel to places like Titan or Mars much quicker than previously thought. Researchers from the University of California in San Diego looked at the orbits of millions of asteroids, moons, and planets and discovered how they interacted with each other. What they found was a new gravitational superhighway system that allowed these objects to move through space faster than previously thought possible. The discovery was made looking at space manifolds, which are invisible structures consisting of a series of connected arches that are generated by gravitational interactions in the solar system. You can think of these as gravity channels. These space manifolds act as boundaries of dynamical channels or connections between gravitational interactions. This newly discovered celestial highway can move objects over several decades as opposed to the hundreds of thousands or millions of years in open space. Such routes can drive comets and asteroids near Jupiter to Neptune in under a decade and to 100 astronomical units in less than a century. Gravity assist can be enabled by these space manifolds and is well known to astrodynamicists. The flybys of the two Voyager missions are prime examples. Voyager 2, for example, obtained a gravity assist from Jupiter, got a gravitational slingshot in a new direction, got a boost from Saturn, then from Uranus, and then the spacecraft sped towards Neptune and eventually left the solar system. The thing is that while scientists knew about these space manifolds, their widespread influence on celestial bodies was unexplored until now. These superhighways may one day be used by space agencies such as NASA and ESA to get spacecraft to outer planets faster, which will create new opportunities for interplanetary travel. Combine this with future spacecraft technology, and humans will soon be exploring the universe. Thank you for watching Dark Core.